What role do you think tall buildings can play in combating China's air quality crisis or similar air quality crisis across the world?
I think that's a really interesting question, because you don't instinctively think of tall buildings as having an impact on air quality, but actually they have it from a number of aspects. You can look at it from a case of just density. You're moving people into one location, and it's going to attract public transport, and people will use cars less, in theory. So that's one aspect of it. Another aspect is that as we design tall buildings, they tend to have very good facades, very good mechanical systems, and so consequently the energy use intensity of a super tall building is going to be relatively low. I mean, perhaps the most simple way is that you look at it as the green space of the country is the lungs of the country. If you're sprawling your houses out into the countryside, you're taking away the capacity to exchange carbon dioxide for oxygen, put everywhere in one building, and then the land outside can start sequestering carbon dioxide, cleaning up the atmosphere and what have you. So I think there's definitely a role to be played, probably in any modern high-performing building, whether it's even super tall or not.
What do you think the role of green walls or sky gardens or incorporating nature into high-rises is?
I think it has its place, and personally I think that place should be quite prominent. I think sticking a huge green wall on the outside of a building might not necessarily be appropriate. I mean, from an aesthetic impact, perhaps it's exactly what you want, but my personal opinion is that to stick a massive green wall on the outside of a super tall building, the actual emissions resulting from maintaining the thing, pumping water up to that height, cleaning the irrigation system out, changing dead plants for new plants, what have you, that's going to outweigh any benefit from it, I believe. But in a smaller scale, where you have multiple use spaces within a building, where you've maybe got some courtyard within a building, an atrium, what have you, with greenery in it. Greenery is absolutely essential. It creates a microclimate, modulates humidity, modulates temperature. People generally, when they have a connection with anything green, feel better. People if you can see out onto green space, the property becomes more valuable. So, for an office that can look out into an atrium that has greenery in it, it's going to be a more interesting office to own than the one that's just, next to the core. So I think that having green space inside buildings is very important, and I do believe that perhaps on podiums and what have you, there's a very good role for greenery on the outside of a building. I just think that you have to be a little bit careful with it, and it shouldn't just be seen as a green adornment, so to speak.
So we've seen net zero buildings on a small scale. We're starting to see more even carbon neutral buildings. What are the most promising technologies that might enable a net zero skyscraper in the future? Do you think that's even possible?
I do. I do think it's possible. I think there's a couple of ways that I could answer that question. There's a regulatory mechanism that's needed first. I think that we probably need to be forced to use more high-performing materials by building code rather than it being an optional extra. But that said, if you really say, I don't care what the code is, I'm going to build myself a net zero skyscraper, I think it is possible. I think that the technological improvements in the building envelope systems and within the mechanical systems are there for us to start using. I think we're an imaginative species. If you set a challenge, we'll figure out a way to fix it. I can imagine at least a net zero tower that would have an extremely high performing envelope using insulation materials that are going to be more expensive, like vacuum insulated panels, triple glazing, adopting, say, passive house level of performance, so super low U value 0.6, 0.7, that kind of thing. It's very easy to get the shadow boxes or spandrels to be less than 0.1, sorry. So you can take care of the envelope. We understand how to make a continuous insulation layer. So now we've got a highly insulated box. It's now just a matter of dealing with the residual solar heat gain or whatever's coming out of the building. And if we can start to look at technologies using perhaps geothermal heat exchange or interseasonal thermal storage in the ground, it's not going to suddenly happen. It's going to happen incrementally. And you know, somebody's going to say, well, these guys did that, and you know, it costs so much. We've learned the lessons from that, and we can do it a lot cheaper, and then you make another step. And so it's kind of really baby steps. But I absolutely believe it's possible.
Technologically, then you'd say it's possible today.
Yeah, I think it is possible today. You know, there's also issues about how you define net zero energy building. I mean, if I'm having a net zero energy super tall data center is probably not going to be possible ever.
Right.
But you know, a net zero energy office building, a law office or something like that, that doesn't have a huge energy demand, sure. It's absolutely possible. You know, we've got extremely smart building control systems that respond to the presence or absence of people in the building. We've you know, to plug load's always a thing that you can't control, so you know, you try to come up with ways to do it, which is kind of beyond our scope generally. But you know, we talk about thin client IT solutions and what have you, and I think that reducing plug load and the residual heat that they generally create, which causes offices to have to be cooled, we can deal with that. All the technology exists to do it, I believe.
Speaking of responsive building design and performance standards, what do you think tall building designers need to do that they're not doing already to address disaster resilience, climate resilience?
One of the outcomes of climate change may be that cities or parts of cities are no longer relevant for the function that they were originally designed. So, for example, you may have a whole load of offices in a place where, for one reason or other, due to climate change, it may no longer be the right place to have offices. So you might want to think of, perhaps, could these buildings be converted to residential properties? So that kind of resilience, I don't think is happening. You know, people are not thinking, well, could I punch a hole in my floor if I needed to, you know, make this I don't know, 2-story apartment or something like that.
Right.
So that's kind of a little bit more abstract, but you can see how it happens. I mean, patterns of city use do change through time. And often that's the drivers for that are, you know, sea level rise, a port comes or a port goes away, or agricultural land becomes, you know, agricultural industry diminishes, and there's all kinds of reasons why cities change size and shape. And
it seems like a difficult question too, because how do you plan for uncertainty?
That's right. It's really tough, and not only that, how do you ask a client to plan for uncertainty when he knows he's probably just going to do a spec office and try and sell it anyway?
Right.
So the responsibility is probably on us to, I wouldn't say do it secretly or surreptitiously, but we just, as responsible designers, we should take that into account and, you know, develop a design principle that allows either the current owner of the building or any future owner to change it to, you know, how they might feel meets the need of the current market in the future.
We talked about net zero earlier on a building scale, but let's talk about it on a city scale or a society scale. Right. Even. I mean, you've planned with Adrian Smith and Gordon Gill net zero cities from the ground up, like Mazda.
Right.
What lessons can be applied from this kind of experience, these planning experiences, to the real world where politics, economics, there are all these harder to predict things that might change the equation?
Well, Mazda was a very unique project. In its initial, the initial envisioning of the project was that it was going to really develop low energy solutions that could then be rolled out in other parts of United Arab Emirates or other cities in the world. As the market changed very rapidly during the period that Mazda was developing,
right.
and the owner of Mazda, basically the UAE government, felt quite rightly, I believe, that we couldn't just use this as a super expensive research project. It's had to start justifying, and there had to be some validity to it. And I think that's one of the big lessons learned is that we have to, sustainability can't be some kind of boutique expensive product that somebody just bolts onto the side of a building. Not that Mazda was bolted on, but it was definitely a boutique high-end project that really nobody else could have ever imagined they could afford, let alone actually afford it. And it actually moved away from that to become something a lot more realistic, and I think a much better product as a result of that. But I think one of the big lessons that we have to learn is that you can't just go onto Google, see some technology that's on, that you heard that some guy in MIT's thinking about doing, and then design that you're building all around that system. You have to, Gordon uses this phrase all the time, state-of-the-shelf technology, and it's absolutely right. When we design a building, we have to, I'm not going to use a product that doesn't have a catalog number and a price list and a warranty. I can't do that to my client. So you know, when one of the issues with Mazda was that they did bring out a whole load of really cutting-edge technology. Some of them didn't work, and you know, they spent money on that, and which is fine if that's what you're doing. But most people can't afford to do that. So
state of the shelf, what's readily deployable and practical versus state of the art.
I think so. I mean, I think that there's always going to be a place for showcasing a new technology, but you shouldn't use it as your backbone unless you're happy and living in a very high risk environment.
Yeah. Remind me of you're working on some other projects that are net zero on a city scale now.
Yeah, one project that I'd like to tell you about is our Astana Expo 2017 project.
Kazakhstan?
It's the capital of Kazakhstan. It's hosting the Expo in 2017. And we're doing the design of several buildings in the main Expo site. In fact, pretty much all of the buildings in the main Expo site. And some of the pavilions we're designing as net energy positive buildings. So, you know, one of the challenges that we face working in a market such as Kazakhstan is that if designing a net energy positive building is one thing, building it is another thing altogether. And so we're reluctant to say they will be net energy positive, but they're being designed to be net energy positive. So like I said before, the thermal envelope of the buildings is absolutely amazing. You know, we're working with the best curtain wall people in the world. Our own guys are the best in the world, in my opinion, for, you know, detailing how you maintain the continuous insulation. Bearing in mind that we want it to be net energy positive during the expo, but primarily these buildings are going to have to last for 50 to 100 years. So, you know, the expo period is 3 months. We're not designing a building for 3 months. We're designing a building for 50 years that for 3 months has to serve as an expo function. Right. And so the main thing is that when the buildings have finished their expo role and they get converted to offices, they can be net energy positive. Or, you know, should they not get built as we would like? And there's no reason to think that might happen. Perhaps I think I'm just an eternal pessimist. But even if that didn't happen, they're going to be extremely comfortable buildings, very nicely daylit, nice temperature indoors. So yes, we're looking at those as a whole load of energy positive buildings at the moment. Actually, in any place in the world at the moment, I think it's the biggest agglomeration of net energy positive buildings altogether. It's a campus of net energy positive buildings, effectively. So that's interesting.
Can we build our way out of environmental crises?
I think we have to, don't we? I think we have to. We have to work with the construction industry and the supply chain, because it's really, you know, so long as we have access to products that can reduce energy, we can take care of operational energy demand. We have a relatively good level of control of that. And even at operational energy demand, if you're living in a country where, for example, Iceland, where all the energy is met through geothermal power, the carbon dioxide emissions aren't very much from the operating of the buildings anyway. Where we really need to move into the space is in the whole life cycle carbon emissions of the building. So looking at embodied carbon, the effect on the environment of producing the materials, the effect on the environment of constructing them and then disposing them at the end of their life. And that's where we have some responsibility to select products that have a lower impact. You know, we're definitely moving into, we're trying to take on a leadership role where in our specifications we require, let's say, insulation manufacturers to provide environmental product declarations that they're insulating materials blown with pentane rather than HCFCs or something like that. So I guess we do have a whole opportunity to build our way out of this, but we can't do it just on our own. It has to be through collaboration with the supply chain, and unfortunately, because we have no real control of them, we also have to work with the legislators to start bringing in benchmarks and minimum standards for some of these things that we might not have included before. I mean, LEED's taking lead, you know, USGBC's LEED program is taking baby steps into doing this with the new version 4, looking at life cycle analysis.
Yeah.
Other rating systems have had that in place for a little while longer. So you know, I think these are going to be interesting times over the next 5 years, and see how this pans out. I think that generally there's an acceptance that we have to. So we have to start looking at the overall, more holistic global impact that we have on the environment, not just on, hey, let's save some energy and have a net energy positive building. I mean, I can have a net energy positive building that actually the embodied carbon, well, obviously the embodied carbon is going to be everything in that case, but the embodied carbon of a net energy positive building is going to be way, 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 way higher than the embodied carbon of a perhaps close to net energy positive building. So the first step is to just, you know, take this leadership position and start evaluating the whole environmental impact of the materials that we're selecting, not just how they can save you operational energy, but how they can perhaps be used to reduce embodied carbon of the overall building.